Today's lesson is on average rate of change. Now remember, average rate of change is the same thing as slope. The formula for average rate of change is f of b minus f of a divided by b minus a. Now remember, slope is for linear functions. Average rate of change is for nonlinear. That does not look like nonlinear, does it? Let's try that again. Nonlinear. Sorry about that. Alright, so remember that f of b means the y value when x equals b, and f of a is the y value when x equals a. So our average rate of change formula is really the same thing as y2 minus y1 over x2 minus x1. The biggest difference is going to be not in the math. The math is going to be exactly the same between slope formula and average rate formula. The difference is going to be how the problems are presented to you. So it is very, very important that these two statements are what you think of when you see f of b and f of a. You're just looking for the y values when the x value is b and the x value is a. You're just looking for slope formula. Okay, so we're going to do 3 different types of examples to prepare you for the assignment that you have. Okay, here are the instructions for the first section of your assignment. For the points A and B, calculate the average rate of change. Now I'm going to go ahead and write the average rate formula here, f of b minus f of a over b minus a. Okay, now for problem number 1, it says point A is negative 5, 4, and point B is negative 1, 3. So first, let's think about if this was just asking for slope. Okay, we might label this one, we might label negative 5x1 and negative 4y1 and negative 1x2 and 3y2. You wouldn't think anything about that. We would plug it into the formula, the slope formula, y2 minus y1 over x2 minus x1. Okay, so in the same way, we're going to label these, but we are going to use our notation from our average rate of change formula. So remember, f of b is the y value when x is b. So the first thing I'm going to do is I'm going to come in here and I'm going to label this x value a and that x value b, because we can agree that a and b are the x values. Well, what that tells me then is the y value for a can be expressed as f of a. And the y value of when x equals b can be expressed as f of b. Now watch what happens. What I'm going to do first is I am going to come over here and I am going to substitute a 3 in everywhere there is a b. Oops, nope, I'm not. I am going to substitute a negative 1 because that's my x value. Negative 1. And then there's a b down here, so I'm going to put a negative 1 there. Now, I'm going to come in and everywhere there's an a, I am going to put a negative 5. F of negative 5 and negative 5. So what I need you to see first is all I have done is I have substituted my x values in for my a's and my b's. It's just substitution. So step 1, substitute x values. Okay, now let's move on down. I've got f of negative 1. f of negative 1 is the y value when x equals negative 1. Well, I can come up here and I can see that f of negative 1 is 3. So I've substituted my y value for my notation f of negative 1. Now I want to do the same thing with f of negative 5. I need to know the y value when x is negative 5. Well, that's over here, the 4. I've substituted the y value for the notation f of negative 5. I'm going to go ahead and bring down my negative 1, and I've got a negative and a minus here, which gives me a plus. Now what I have done here in this step, I substituted y values for my f of notation. Okay. Now step 3 is just to simplify. So now I've got 3 minus 4 is a negative 1. Negative 1 plus 5 is a positive 4. I cannot simplify this anymore. So my average rate of change between these 2 points is negative 1/4. Let me move that back down. Oops. Let me move that back down so you can see the whole problem. Okay. Pause it, look at this, make sure that you understand all the steps, and then hit play, and we will do another example that has different instructions to it. Hit pause. Okay, here is the next instruction. For the function f of x on the interval a, b, calculate the average rate of change over each of the given intervals. Now the first thing we need to pay attention to is this right here. This is not an ordered pair, it is an interval. In other words, this is an x value and this is an x value. So if you were looking at a graph, it would be something like this. From this point at x equals a to this point at x equals b, I want you to find the average rate of change. Okay? Now remember, all of the intervals we've been doing have been pieces of the domain. We're always focusing only on the x values. Okay, I'm going to erase my little graph. Alright, so what we have is we need to find f of b minus f of a over b minus a. Here I know that x equals negative 5 and x equals negative 1. I'm going to go ahead and call my first x a, and I'm going to call my second x b, so that we know which x is which. Okay? So I'm going to go ahead and substitute step number 1 from before. I'm going to substitute in my a and b values. So f of negative 1 minus f of negative 5 divided by negative 1 minus a negative 5. So here we just substituted. From here to here, we substituted x values. Okay. Now, what we need to do is we need to find the y values. But if you remember, on the last problem, we were given the y values. Here we're not. But we are given a function. So if we've got an equation and we've got x values, we can find the y values. So I'm going to go ahead and do this in yellow. I'm going to rewrite my equation here. 3x plus 1. I need to find f of negative 1. Well, all that means is I'm going to substitute negative 1 in everywhere there's an x. 3 times negative 1 plus 1. So this is negative 3 plus 1, or negative 2. So I'm going to come over here, and where there was f of -1, I'm substituting a -2. Okay? But now I need to find f of -5. So I need to come over here and find f of -5. Again, I'm substituting. Everywhere there was an x, I'm going to put a -5. So this gives me -15 plus 1. -15 plus 1 is -14. So I am substituting that over here everywhere there was an f of -5. So remember, our second step on the page before was substitute y values for notation. Okay. Now I am going to go ahead and bring down my -1. This minus a negative here gives me a +5. And now I'm just going to simplify. So I've got -2, and again here we've got a plus again, minus a negative. -2 plus 14 is 12, and -1 plus 5 is 4, and 12 divided by 4 is 3. So my rate of change is 3. So I'm going to pull this back down. Let's make sure we've got all of our steps. We took our interval and we rewrote them as our x values a and b. Then we substituted these into our notation. Then we came over here and we found our f of -1 and our f of -5 values, and we substituted them in here. And then we simplified. Okay, so we're going to do the same thing, but with different interval. Okay, so hit pause, look over this, and we're going to work another one. Okay, this is the second piece of, or the second interval for number 4. So we're doing the exact same process. F of b minus f of a over b minus a. We are given the interval a equals, that's an ugly a. Let's try that again. A equals 2 and b equals 8. And again, remember, these are just x's, but I'm giving them different names so that we can tell them apart. Okay, so I'm going to substitute f of 8 minus f of 2 over 8 minus 2. Okay, so we've substituted our x values in. Now I need to come over here. I'm rewriting my function. I need to find my values of f of 8 and f of 2. So 3 times 8 plus 1, 24 plus 1 is 25. So I am going to substitute 25 in for my f of 8. Then I am going to find f of 2. 3 times 2 plus 1, 6 plus 1, 7. And I'm going to substitute 7 in here for my f of 2. Bringing down my 8 minus 2. And now I get to just simplify. So 25 minus 7 is 18. And 8 minus 2 is 3. Nope, 8 minus 2 is not 3. 8 minus 2 is 6. I was jumping ahead because 18 divided by 6 is 3. So again, our process is the same. We labeled our x's as a and b. We substituted those into the notation. We came over here and found the values for f of 8 and f of 2, and we substituted them into our equation, and then we simplified. So that's the second type of problem that you're going to have on the assignment. Let's look at the last one, and we will be done. Okay, so number 7 on your assignment is going to ask for you to calculate the average rate of change on the given interval, given this graph, for the interval -8, -6. Okay? That is a really bad 6. Just a moment. Better. Okay, so the first thing I need to do is look at my function, f of b minus f of a over b minus a. Okay, again, I have my a equals -8 and b equals -6, so I'm going to plug those in. F of -6 minus f of -8 over -6 minus a -8. Okay, so I'm still plugging it in just like I did before. But look what happens. I no longer have an equation to plug these numbers into. All I have is a graph. So what I'm going to do is I'm going to come over here, since -6 is an x value, I'm going to go to my x-axis. I'm going to come over here until I find -6 right here. I need to go up and find the graph. Here is a point on the graph. That point, as you can see, has the ordered pair -6, +4. Well, what is the y value at that point? It's 4. So I am replacing f of -6 with the 4 I just found on the graph. I think I'm going to actually make that green. Okay. Alright, so now I need to do the same thing for f of -8. So I'm going back to the x-axis. I'm going across until I find -8. Well, look at that. The graph actually is crossing the axis right there. So as you can see here, the point is -8, 0. So the question is, what is the y value at that point? The y value is 0. So I am going to plug 0 in for f of -8. Then I'm going to bring down the rest of the problem. I'm going to go ahead and look at that minus and negative and make that a +8. And now we're right back at the simplification process. Okay, so 4 minus 0 is 4. -6 plus 8 is 2. And that simplifies to a rate of change of 2. Okay, so let's do one more of those. Okay, so this time we are doing it for this interval, -6, 1. I went ahead and wrote the function. So let's plug it in. I've got f of, I'm going to use f of 1 minus f of -6 all over 1 minus -6. Okay, so we've plugged them in. Now I need to go find the y value at f of 1. So I'm going to my x-axis because that is an x value. I'm going to come across here until I find x equals +1. That's right here. I am going to go down until I find my graph. I have a point right here. This point is 1, -7. You can't see that very well. Let's do this. There. Let's try one more color. There we go. 1, -7. So what is the y value there at that point? It is -7. So So I've taken this notation and substituted -7 in for it. Now I'm going to do the same thing for f of -6. I'm going back to my x-axis. I'm coming over until I find -6. This is a point we've already used. What is my y value here? My y value is 4, so I am plugging in a 4 for that f of -6. Now I'm going to go ahead and come down here, -1, I'm going to go ahead and do this minus a negative as a plus, and now I'm simplifying. -7 minus 4 is -11, -1 plus 6 is +5. Nope. This should not be negative. Sorry. I did that in class too. I added a negative to that for some reason. +1 plus 6 is a +7. This is your average rate of change. So this should take care of all three types of problems. Again, the math is exactly like slope. It's interpreting and finding those y values that gives us the challenge. So practice that and let me know if you have questions.